Hi, this is Pre-Algebra Lesson 46 on multiple graphs. Today we're going to make comparisons, predictions, and inferences using information displayed in bar graphs, line graphs, and pictographs. This is SOL Objective 813. One thing that you're going to see over and over again when you're studying statistics throughout math is to find different measures of center or different types of averages. And here are the three most common ones: mean, median, mode. Now I know you've seen them often, but I just want to review them for you and have you put them in your notebook. Mean is when we're finding the average value that represents data, and then you divide all of the parts together. So mean is when all of your numbers are usually clustered together. You don't have any very high numbers or very low numbers. Everything is kind of put together, like the number of students in middle school, or the ages of students in a particular grade, or the heights. But when you start talking about a large group of data that represents wide variety of things, and you might have some numbers that don't fit in a cluster, you would not use mean then. So again, mean is the average when you are using numbers that are similar. You're going to add them all together and then divide by the total number of pieces of data to find the average number. Median is different because you're finding the middle value. And that's where you line up all of the numbers from least to greatest, regardless of whether they're clustered together or not. They're all lined up, and you figure out who or what piece of data, or two or three pieces of data, are in the middle. And if there's two pieces in the middle, then you want to add them together and divide. But otherwise, the median is a center of measure that, again, you might have some really high numbers, some really low numbers. Like if you were talking about prices of houses, some houses might be really, really high, some houses might be really, really low, and then there's a lot that are kind of in the middle. If we talked about ages at school, the median would be used if you were comparing the teacher's age with the student's age, where a teacher's age would probably be way out of the realm of everybody else, but the students are more clustered together. So again, median is when you have what we call outlier numbers. And then finally we have mode, and mode is where we find the value that represents the data that's most often occurring. This is usually used with categorical data, or data that's not number driven but word driven. If you were asking who your favorite team is that's going to win the Super Bowl, what their favorite color was, those kinds of questions. When you're answering with a word choice and there's a repeated value over and over again, that's when you're going to use the measure of center of mode. Okay, go ahead and pause the video and copy these into your notebook. So I said we're going to talk about graphs today. We've already talked about histograms, and we've talked about circle graphs. Today we're going to talk about three more types of graphs that we've seen in the past, but we just want to make sure that we really understand how to use them, and then how we can get information from them compared to the other types of graphs. So the first one we're going to look at is this one. It's called a pictograph, and it's a pictograph because clearly it shows lots of different kinds of pictures on there. That's how the data is represented. Okay, so when we're looking at this particular pictograph, we're looking at the varieties of apples in a food store. So we have all the different kinds of apples. Some of them I've never even heard of. Many of them I'm quite familiar with. I'm sure you are too. And we're looking, each apple represents a value that is shown in our key. For instance, one whole apple represents 10 real apples, and then clearly half of an apple would represent 5 apples. So when we're looking, for instance, at the Red Delicious, we have 1, 2, 3, 4, 5 whole apples, so that really represents a total of 50 apples. And we looked at these in the past, probably in elementary school and early middle school, but we want to make sure that we can continue talking about them in upper middle school and high school as well. Okay? So the question today is, how many more red Rome apples are there than Macintosh apples? So how many more? So we're comparing the Rome apples to the Macintosh apples. So let me use a different highlighter. So if we look at the Rome apples, red Rome, we're looking at these, and we're comparing them to the Macintosh apples, which is these. And we're saying, how many more are they? I'm sorry, how many more are there? So I'd like you to go ahead and answer that question and write your results down. Keeping in mind, if you look at the Macintosh, we don't have full apples all the way across. Excellent. Okay, let's go on to our next graph. Here is a typical bar graph, and our bar graph is where it's showing categories down below. Yesterday we talked about histograms, and the histograms show it's a type of a bar graph where there's no gaps in between the bars. And today we're talking about just a traditional bar graph where one bar represents one specific category and it's not continuous, so there should be a gap between each of these. This, for instance, A does not bleed into B. Like there's nothing in between A or B that would make it continue. So therefore it would be completely separate from each other. So what's different about the bar graph is that on the x-axis we are seeing categories. These are values that represent different types of answer choices. So in this case, we're looking at letter grades for a test. So we have a grade A, a grade B, C, D, and F. And we're seeing how many people, or what was the percent of people that got each one of those grades. Okay, we don't know exactly what the values were for the A. We don't know what the specific scores were for the B's, the C's, the D's, the F's. We just know that overall those were the grades. And that makes it different than the histogram. Okay, on the side, on the y-axis, we're still seeing more of a frequency type value and label. So this is percentage of students is the label here. What we don't see, unfortunately, on this graph is we don't see the title that should be across. We know that for graphs and tables to be complete, all of the components would need all the different labels, and this one does not have a graph label. So we could say like social studies test grades. That might be a label that we would want to have. So in this particular problem, we are saying the bar graph shows the percent of students that got different grades on a test, and we want to know what was the average grade. So we can't just look at it and say, oh, the average grade was C because it has larger. We would need to know, we were going to add up how many people got A, how many people got B, how many people got C, how many got D, and how many people got F. So we would want to know overall how many people took the test, and then we're going to divide it by the total number of types of grades that we have, and that would give us the average grade. We see that more people got a C, but is that truly the average grade on the test when we have the range of A, B, C, D, E, and F, or not E, A, B, C, D, and F? So again, add up how many people took the test, because we're averaging how many people of each, and then we're dividing it by the types of grades that there were, which were the A, B, C, D, F, and then that would tell you what the average grade was. Okay? Go ahead and figure that out. And our last graph today is a line graph. A line graph is a continuous graph. It shows a line that continues over time. We're looking at the same type of topic. In this case, we're looking at Sam's weight, and we're seeing how does Sam's weight change over time. Another typical type of graph that we would see is the stock market. How does the stock market change over time for a particular stock? How does the weather change over the days of the month? Those types of graphs where it's continuous, we're looking at the same category over time. That's what's different about a line graph. Okay, here's one title. another title, and the third title. So it looks like they've done a great job of making sure that it has those components. Again, the categories are categorical, so this is a qualitative type graph where we can check the quality of things. We know that we're looking for categories, not numbers necessarily. Okay. So the information does give us some numerical value, and in this case it says what is the line graph shows Sam's weight over the months, and we want to predict, using this information, predict what Sam's weight would be in July. So we see the graph only goes to May, but as we're watching the trends of the graph, how it's going up every month, and how we might want to see how does it change every month, and do we see a trend, and what would we expect to happen then in July over if we kept going on and on. Okay, go ahead and make a prediction of what you think his weight would be in July. Great. Okay, so tonight your homework is to record the answers that you had for all of the questions that on the graphs that we discussed, and then I want you to create your own graphs that are similar to the ones discussed in the lesson today. We discussed a pictograph, a bar graph, and a line graph, and I would like you to make your own versions of the three of these. Don't simply copy the ones that you saw, make your own. You don't have to include any questions, but definitely include all of the components of those graphs. See you next time.